Chapter 10, Section 5 in the 7th grade note-taking guide is entitled Surface Areas of Pyramids and Cones. So I'll start off here. We'll give us some terminology related to the pyramids and the cones that we will find important here when working with the formulas. A regular pyramid is a pyramid with a base of a regular polygon, and the other faces are congruent isosceles triangles. Now, in case we've forgotten there what a regular polygon is, a regular polygon is a shape where all the sides of that shape are congruent and all the angles of that shape are congruent. And usually the first idea we come up with there is a square. A square is the best type of regular shape that it's just most commonly associated with that idea. That's exactly what you should be thinking of as the base here. The base is not going to be some weird octagon with different side lengths. You're not going to have that here when we're talking about the regular pyramids here. The base has to be a regular shape. And the triangles that go around the shape have to be isosceles. Isosceles means the two sides are the same. All right, we've got the idea of the slant height of a pyramid. The slant height of a pyramid is the distance from the vertex opposite the base to the midpoint of an edge of the base of the pyramid. So if we're looking at the triangles that go around the pyramid, we're literally measuring up the triangle now. We're not talking about how tall the whole pyramid is, because how tall the pyramid is going to go from the point of the pyramid, from the tippy top, all the way down to the middle of that regular shaped base. All right, the slant height is going to be the height up one of the triangular pieces. Slant height of a cone, same idea. That's the distance from the vertex to the point on the edge of the base of the cone. So as we actually take our finger and slide it down from the vertex, the tippy top of the cone, to some point on the circle itself, that's going to be the slant height. Now, talking about the height of the cone is going to go from the tippy top to the middle of the circle, the center of the circle, the center of the base. All right, that's just the regular height. We're talking about the slant height. If I ran my finger from the tippy top down the side of the cone, all right, that's going to be the slant height. All right, so number one here, they're asking me to find the surface area of the pyramid. So the first thing they gave us here was the formula. The formula is not too bad, but there is some different things in there. As you can see, the first thing there is B. B, as you already know, is the base, the area of the base. We found the area of the base many times before in other formulas. And then we're going to add to that 1/2. We're going to multiply that 1/2 by the perimeter of the base, which is what P is. We've seen that before. And then L, that's the new one, but we just talked about it. L is the slant height. So once we multiply together 1/2, the perimeter of the base, and the slant height, and add that to the area of the base, that's how I find the surface area of my pyramid. So, as far as finding the area of the base here, as you can see, the base measures 9 by 9 here, or in other words, 81. So it's 81 plus 1/2 times the perimeter of the base times the slant height. All right, as far as finding the perimeter of the base, we can do that. Since this shape here is regular, because remember, we defined regular right in the beginning here, all the sides have to measure 9, because that's the only way it can be regular is if all the sides are the same. So if one side is 9, we have 4 9s there for the perimeter of the base, 9 plus 9 plus 9 plus 9, which is 36. And L is the slant height, the height up one of the triangular faces of the pyramid. Again, the regular height, as we've already seen when we did volume, drops down from the tippy top to the center of this base. It would be right in here. They don't even draw it here because we don't need it for surface area. We're talking about the slant height, the height up one of these triangles from the edge of the base to the tippy top. And even if I did it on this triangle, or this triangle, or this triangle, because those triangles are congruent by definition, any way you do it, the slant height here is 10. So over here I've got to simplify 1/2 of 36 times 10. Well, 1/2 of 36 is 18, and 18 times 10 is 180. So to find the surface area here, I'm adding together 180 and 81. But when I add together 180 and 81, The result is 261. So the surface area here is 261 square meters, or 261 meters squared. All right, now here's our cone. Now the cone uses the exact same formula. The difference is again, as we've seen in all the sections we've done here, the formula here is specific now to the cone. Because when I'm talking about a cone, we know that the base, for instance, has to be a circle. So where I was doing things with base before, now I can literally just lay that out to say it's a circle, use the formulas for a circle. So as you can see, the formula here says I'm going to take pi and multiply that by the radius squared. And I'm going to add to that pi times the radius times the slant height, once again, which is what L is in that formula, that cursive L. And once I find each of those products for each set there, I'm going to add those together, and that's going to give me my surface area. So 3.14 times the radius squared, well, the radius is clearly labeled 3 there. Just want to make sure if they give us the diameter, we cut that in half. Over here on the right side, pi, 3.14 times the radius 3 times the slant height, the height up the side of the cone. Again, the height would go from the tippy top to the center of the base here. But they don't even draw that here because I don't need height. I need the slant height here, which is 10. So I've got 3.14 times 3 squared, in other words, 3.14 times 9 here. 3.14 times 9 is, of course, going to change into 28.26. Over there, I've got 3.14 times 3 times 10. That's the same as 30 times 3.14, which is 94.2. I'm going to go ahead and add these guys together here now. The 94.2 added to the 28.26, and the result there is 122.46. So the surface area of that cone is 122.46 square centimeters, or centimeters squared. All right, so let's find the surface area of the pyramid here in the first check it out example. Again, the formula says, start off, you want to find the area of the base. So as you can see, the base, the sides are both 7. 7 times 7 is 49. All right, we're going to add to that 1/2, which is just part of the formula, times the perimeter of the base. So what we get when we add up the 4 sides. So a 7 and a 7 and a 7 and a 7, that's going to make 28. 7 times 4 is 28. Times the slant height, which is L, that's the height up one of the triangular faces, marked at 12. Well, that's not too bad. We can do that pretty quickly. We've got half of 28 there. Half of 28 is, of course, 14. And 14 times 12 changes into 168. So this is the same as 49 plus 168. And 49 plus 168 is going to change into 217. So that's going to be 217 millimeters squared, or square millimeters. As we look at the other example here, where we're finding the surface area of a cone, again, the formula says take pi, which is 3.14, and multiply that by the radius squared. So 3.14 times the radius of the circular base, which is clearly marked at 2. So times 2 squared, which of course we're going to change into 4. 3.14 times 4 is 12.56. Other side of the formula says take pi again, multiply that by the radius, and then we're going to multiply that by the slant height. So that's 3.14 times 2 again, times my slant height, which is 8. 3.14 times 2 is 6.28, and 6.28 times 8 changes into 50.24. So I'm adding together 50.24 and 12.56. When I add these two guys together here, 50.24 plus 12.56 is 62.8. So we've got a surface area of 62.8 square feet.